So we're starting with TLC today. And what is TLC? It's thin layer chromatography. So what is a thin layer? There is a glass plate here, and on top of it there is a powder. It can be alumina or silica. And this powder is what we call a stationary phase. So the idea is to put your substance on the stationary phase, which is a solid that will interact with your substance through intermolecular forces. And depending on the strength of the intermolecular forces, your substance can strongly adhere to that surface or weakly adhere to the surface. Now, what you also do is once you have your substances on the surface, then you're going to use a liquid phase that will push it up. So we always have two phases, a stationary, which is the solid, and a mobile phase, something that moves, and in this case it's going to be the liquid. And what happened when you develop a TLC plate, the liquid will be pushing your substance upward, and of course it will push it based on the intermolecular forces it makes with your substance. So you have two competing intermolecular forces, the ones between your substance and the solid, which is the stationary phase, and the ones between your substance and the liquid, which is the mobile phase. So before we develop a TLC plate, we have to prepare it. So how do we prepare it? You take the plate and you're going to put a few dots wherever you're going to put your substances about a ½ centimeter above the bottom of this plate. And this is what I did. We have here a plate that is ready to go. So a ½ centimeter from the bottom, I used a pencil and very slightly I put few dots. So here we have 5 unknowns, and I put 1, 2, 3, it should be 4 or 5. We have 5 known substances and an unknown substance that I put an X on it. So what am I going to do now? I'm going to spot each of the substances on this plate, and then we're going to put it in a jar where we're going to develop it with the liquid phase. But before I start spotting the substances here, I want to prepare my jar, my developing jar, because you want to saturate it with the liquid. So what goes in this jar? See, this jar has to have a cap. You really need to have it closed environment. So that's the reason we use this type of jar. You take a filter paper and you fold it in half, and then you put it in the jar just like this. Now, why the filter paper? If you read the handout, it tells you the filter paper will absorb your liquid and it will saturate this whole jar with that liquid. Now, what type of mobile phase we're going to use in this experiment? The procedure tells you you're going to use ethyl acetate and glacial acetic acid. So ethyl acetate, we need 9.5 milliliters, and we need 0.5 milliliters of the acetic acid. Now, how do we use a graduated cylinder? This is very important. I see sometimes students holding it and pouring the liquid in. That's never the right way. So what you do, you put your graduated cylinder on the flat surface, then you're going to bring your liquid and you're going to pour it in, and here it's best to use a pipette. So what is the liquid, the mobile phase? As I said, we have ethyl acetate, and you notice that I put my eye level to the level of the graduated cylinder and not the other way around. The graduated cylinder must be on a flat surface, and I'm going to fill it up with 9.5 milliliters of ethyl acetate. It's better to go slowly and do it right than go fast and have to redo it again. So 1 pipette at a time, And when you get close to that 9.5, you go 1 drop at a time. Okay, I'm getting very close here, so I'm going to add 1 drop at a time until I reach 9.5, and that's 9.5. Now the next liquid is 0.5 milliliters of acetic acid. And notice, guys, when you work with acid like this, don't put the stopper on the surface. Make sure you hold it. And we're only going to add about 0.5 milliliters here. Now, if you go a little bit above 9.5, it's okay because it's not a precise amount, but try to get as close as possible from 9.5. Now I'm going to transfer the liquid in the jar and allow the filter paper to absorb some of that liquid to saturate this environment. So I'm going to keep it aside while I spot the substances on my TLC plate. Now, how do you do this? I have here my 5 knowns in order. I don't have room on the TLC plate to write their name, so I just put 1, 2, 3, 4, 5. But make sure you take note of what is 1, 2, 3, 4, and 5. Make sure you know on your lab notebook what each substance is. So for my number 1 is aspirin. All you need is basically the tip of a scapula, a tiny bit, about a grain of rice, the amount of about a grain of rice on the tip of your scapula. And then you add a few drops of ethanol to dissolve it. So here I have my ethanol, absolute ethanol, meaning it doesn't have water in it. Just put 3 drops, should be enough. And then you're going to use a capillary. It's a capillary with open-ended on both sides. And you're going to dip, make sure that you dissolve your substance. It is soluble. And you just barely touch your TLC plate with that liquid. Don't push too hard, because if you push hard, you're going to create a disturbance on the solid phase, and that will give you a bad path for your substance. It will move in a wiggly way instead of in a straight line. So all you have to do is just touch it, just like this. You have like about a 1 millimeter, I don't know if it's visible, but about a 1 millimeter spot of liquid in there. When you're done with that first substance, make sure you have a beaker for your waste, for your used capillary. Then you go to the next one, and you repeat. A tip of the spatula of the substance in your watch glass, few drops of ethanol, and you start all over again. So here's another substance that comes in little flakes like this. What we suggest, and that's the reason we use a watch glass, is to use the glass rod and crush it slowly without really going too hard on this. Just crush it a little bit to dissolve it. So first you crush it, make it slightly powdery here, and then, as usual, you put a few drops of your ethanol and make sure it dissolves, and then you spot it on your TLC plate. And now I'm ready for my unknown. The unknown here is a powder. Do the same procedure, put a little bit of the unknown, again about the size of a rice grain, a few drops of ethanol, and you spot it on your TLC plate. So I think this is pretty good. Now we have our TLC plate ready. A good thing to do at this point is to check underneath a UV light if you have enough substance. There are two possibilities. Either your solution is too diluted when you dissolved your crystals and you're going to have very little substance, or you spotted too much liquid, you put too much of it, and you're going to have a concentrated one. It takes practice, and ideally just touch it once, but sometimes you have more than what you need on the TLC plate. So let's check it out and see how it looks like under the UV light. So now we're ready. We checked it, and we have enough substances on our plate. We spotted enough substance, so now we're ready for the jar, the developing jar. The key thing again is you want the liquid to move slowly without disturbance. You want all of it to move at the same pace. So you have to slowly put your TLC plate in the jar and make sure that the back of it touches the filter paper. So this is how you should put it, slightly, slowly, and let it sit against the jar walls. And then you close it. That's the reason we use these jars, because if you let it open, your mobile phase will evaporate outside and it won't do the work it's supposed to do. And now at this point, you start to see that the liquid is moving up, and on its way up, it's pushing with it these substances. And of course, they're not going to all move at the same rate, and that's what we call later we're going to measure at what rate each one of these move to identify our substance. So we're almost done developing this plate. So what does it mean, done developing? Is when your liquid reaches that line that we're going to use to calculate the distance the liquid traveled compared to the distance the substances traveled. So you have to keep an eye on it and get really, really close. And it looks like for us, we're almost there. It takes about 7 minutes to develop the jar. So I don't know if you can see it very well, but I can see that the liquid is at that level of the pencil line. So at this point, you can open the jar and pull your plate and let it sit until it dries. So here's my plate, and you see that it dries from the top faster than the bottom because you have less liquid, and it looks like almost like two different layers. So at this point, while we wait for the plate to dry, because you don't want the solvent on the surface, you want it completely dry, you just put it on paper like I did and allow it to dry. In the meantime, you can discard your liquid. So by the way, it's a good habit to always have a beaker for chemical waste. So all you have to do is just pour it in that beaker, and you can either discard the filter paper. We should discard it, and we have in the fume hood a container that says solid waste. So you can take your filter paper and put it in the solid waste. And while we wait, I want to show you one more thing, is that the used capillary, we have a container here, it says used capillary tubes, and it will be in the fume hood, but for this purpose of the video, I'm showing it right here. All your capillaries that you used should go in this container. Okay, now it looks like our plate is dry, so we're ready to see it under the UV light, because as you can see here, we don't have any way of gauging what are the substances. So at this point, when your TLC plate is ready, you're going to bring it in this box where we have UV light. So what you do, you see we have like this black felt to cover. You put it inside and you push on the button. Of course, we can't see it from the video here, but you push on the bottom from the UV light to turn it on, and with the pencil, you go inside and then you circle, you contour the different spots. The TLC would look like all the spots would be fluorescent, and all you have to do is just make a quick little line around each of these spots. Okay, so you go underneath this dark, in this dark chamber, and you circle your spots, but for both unknown and unknowns. And then once you have all your spots circled, you end up with something like this. And at this point, you can measure the distance for the solvent and the distance for the substances. So for each substance, what you do is you take the middle of your spot and you measure the distance from the starting point to the middle of the spot, and then you divide that distance by the distance of the traveled by the liquid, and that would be your RF.